ready for you by the end of the lecture.
All right. Up here, por favor. There we go. A function. First of all, write the following down. There are 5 words that define a function. One input yields one output. Go ahead and write that down and I'll explain what it means in a second. One input yields one output. Take special note of the word yields. To yield means to give. If you yield, like the yield sign on a street is yielding the right of way. So you give the right of way to somebody else. If you yield your possessions, that means you give them up. Now, what does this mean? An example. This is what we call function notation. In other words, what does a function look like if you ran into one in the wild, so to speak? It looks like this. F parentheses x equals x squared plus 3x plus 2. This is an example. So what is a function? First of all, how do you say this in English? This looks a lot like f times x. It is not. Take special note right away. Normally parentheses, like squished together with something, means multiply. So 90% of the time that's true. But when you have a letter without parentheses, followed by a letter in parentheses, that's a little different. If there were parentheses, it definitely means multiply. But this is pronounced f of x. It's pronounced f of x. It's short for function of x. F of x is short for function of x. That's what it means. Well, that's what it says. So what does it mean? A function of x, let me just rewrite this up here. You don't have to rewrite it, it's just I was running out of room. X squared plus 3x plus 2. This letter right here, the f, is the function name. In this case, the function name is f. This is function f. This inside the parentheses is the input variable. It's what you plug in. This is basically a machine. You feed it numbers and it spits out different numbers.
Yeah.
This thing on the end, the x squared plus 3x plus 2, is called the output formula. So if you wanted to say this in English, you would say f of x equals x squared plus 3x plus 2. Does that make sense so far? So this is a function. How do you recognize it as a function and not just a multiplication problem? First of all, they do equals a formula. That's a dead giveaway. And letter without parentheses followed by letter in parentheses. That's not going to happen anywhere else except a function. So what do we use it for? Let me give you a quick example. And in order to take a guess what I might mean by that. It looks like f times 10. It is not. It's using the same function notation, but what are they asking us to do? Take a guess. No doubt that will be wrong. No doubt that will be anyway. Yeah, go.
Well, function of 10.
Function of 10. Yeah, it's f of 10. What does that mean? So what do you actually do with the 10? I want to take a stab at guess. There is something you do with it. Yeah.
I believe you put it in 4 letters.
Look at the x. You notice it took the place of x? It's going to take the place of x here as well. You put it in place of the letter, exactly. So, by the way, whenever you plug anything in, always use parentheses. Whenever you plug anything in, gift wrap it, so to speak. So this is going to be 10, I'm going from here, 10 squared plus 3 times 10 plus 2. See how I did that? That's how a function works. You plug a number in and use it. You use it in the formula. You will eventually get an answer. Let's find out what the answer is. Well, people who remember your order of operations, that's...
Wait, is this substitution?
Oh, is it substitution? It's not the substitution factoring method, but yes, it's substitution. Anytime you replace one thing with another, it's called substitution. This is not factoring, but it is a type of substitution. Yes. So how do you do it? Yes. Wondering. Go.
Did you start with 10 squared?
Yeah, because what's the order of operations say? What do you do first? Well, first parentheses, then exponents, then what? Remember. Multiplication and division, and then finally addition, subtraction. So parentheses, then exponents, then multiply, divide, then add, subtract. Quick question, see who remembers way back when. What do you do first, parentheses or addition? Draw it. What do you do first in any problem, parentheses or addition? Definitely, because that comes first in order of operations. Sophie, what comes first, multiplication or subtraction?
Multiplication.
Definitely. What comes first, trick question alert? Multiplication or division? Go.
Whichever comes first from left to right.
Whichever comes first, from left to right. Multiplication and division are the same thing. It's just one's going forward, one's going backward. So it's kind of like asking, what do you do first? Multiply or multiply? Well, you multiply. So you do it from left to right. So multiply and divide are the same rank, add and subtract are the same rank. But parentheses is the highest rank, exponents is the next rank. So do exponents first. So Cece, take over.
It'd be 100.
100.
And then plus 30.
Now you can do the 30.
Plus 2.
So what do you get total?
130.
Right. So you could say that f of 10 is equal to 132. So actually calculating it isn't all that bad. You just have to know what to do. Does that make sense so far? We're trying another one. F of, yeah, let's be creative. F of negative 2. I mean, I gotta take this one. What would you plug in for x?
-2.
Exactly. I'm going to use parentheses. So actually, here's kind of what I do when I'm writing up an answer key. I do this. Thingy squared plus 3 times thingy plus 2. I leave blanks there and then just fill them in. Why? Because otherwise I'm going to space out and forget one. So I'm going to do negative 2 parentheses squared plus 3 times negative 2. Nice. Take over Athen. What do you do first?
You did the exponents.
Right. What's negative 2 squared?
4.
Positive 4 or negative 4?
Positive.
Positive. Why?
Negative times negative equals positive.
Right. Negative 2 times negative 2 is positive 4. Keep going. Plus.
-6.
Okay. Plus.
2.
So what do you get?
0.
0. By the way, that's a total accident. That's, well, it's a coincidence. Yeah. Oh.
I don't understand the add part. Like,
Oh, that's the name of the function. For example, does everybody see the technique of plugging in the number and doing something with it? Like, we just use the formula to get the answer. That's pretty much all we're doing so far. Let me show you what I mean as far as what the function name, like what use is it? It has a use when you have more than one function lying around. You have to tell which one is which. Quick example. It doesn't have to be f. F is the nicest one because it stands for function. But you could name the function anything. You could call it g, you could call it q, you could call it a. For example, f of x equals 3x plus 1. And you can use any formula you want I'm going to give you another function. G of x equals x squared. And just to make it a happy family, h of x, a third function, is equal to, x over 2. I've just given you 3 separate functions. So here's my first question to you. What's g of 10? Olivia, take this one.
So G is of 10.
Yeah.
So should I start with the top one?
Good question. Which function, they want you to specifically use one function and only one function.
So G.
Exactly. Skip f, ignore it, and skip h. Use only g. Go ahead.
Basically, we plug in 10 for x, so it's basically 10 squared, which
Correct.
would be 100.
Exactly. G of 10 is 100. The name of the function tells you which function to use. That's its only purpose, really. Max, take the next one. I'm going to give you a little bit of a curveball here. F of 10 plus h of 10. You're going to have to use 2 functions in this thing. One at a time, my friend.
Okay, so.
What do you do to this thing?
So we plug it in for x on the function.
Top function, function f. So what does that look like?
Wait, what am I plugging in? 10, okay, so it would be 10.
It's just like, I'll get all the way. Oh.
It would be 31.
Well, show the word first then. 3 parentheses 1.
3 parentheses 10.
10
Plus 1.
plus 1. And then add that, I'm going to put phantom parentheses around that. That came from here. And then plus what?
Plus.
H of 10. Which of these are you going to use?
Oh, the bottom.
Yep. So what does it look like?
So 10 divided by 2.
Exactly. Now, tell me what you do first. Joe, take over.
10 times 3,
Yes, it is what?
30,
30.
plus 1, 31.
Well, I'll do that in a minute. I don't add until I finish.
So 10 divided by 2 is 5.
Is 5, exactly. So we do multiplication division before we add and subtract. Now go ahead and add on.
31 plus 5,
Which is?
36.
Got it. So f of 10 plus h of 10 is 36. We didn't know that until we actually tried it. Does everybody see how this works? I could give you 20 different functions, and as long as you know which ones to use, I'll actually just plug a number in and get a number out. Okay. I mean, there are some really grotesque functions in the world, and there's some really nice functions in the world. X squared is relatively nice. I've seen some beastly ones that would make your hair curl, but I did say that a function, can anybody tell me the 5 words they use to define a function beginning of the hour? I did. Yeah. One input yields one output. One input yields one output. Let me show you what that means. True function, oh, by the way, function, there's an abbreviation for this. I use this a lot just because it's easier. FN. FN is the accepted abbreviation for function. There's no period, just FN. So, why? Because it's less letters to write. You can feel free to write the word function, that's not a problem. True function versus a fake function. Is it possible to have a fake function? Yes. Kind of like it is to have a fake ID. Every once in a while.
Hi, I'm 21. Can you please repeat that?
It is, this looks like your school picture.
No, but really, I'm 21.
Okay, go on. So it is possible to have a fake function, just like you have a fake ID. How do you tell the difference? There are things that will give it away. A true function, you plug in one number. Oops. You'll get out one number. It doesn't matter what number it is. But if you plug a single number in, you should get a single number out. That's a true function. A fake function, plug in one number, you get out more than one number. I'll give you an example on that in a minute, but let me just show you, well, I'll give you an example now, and then I'll show you a real life example. Example. I want to say f of x equals 5x, and g of x is equal to the square root of x. Quick reminder, this and this are two different things. They're related. This plus, if it was just by itself without plus minus, it's called a what? Go. It's called a radical. It only has one answer, and that answer is positive or 0. It's not negative. This thing is called a what? Okay. A square root. Sometimes called square roots. It has two answers. Positive and negative. So there's a big difference. This is not a radical x. This is a square root of x. So my question to you is, without even plugging things in, which one is fake? Elijah.
The function g.
Yeah. G of x is fake. Why do you say that?
Because it is a square root and you can get two numbers out of it.
Right, let me show you. Let's just say g of 25. Try that. Elijah, go for it.
225. So you plug in it with the x.
So what would it look like?
Square root of
Yeah, plus or minus the square root of,
25.
what do you get from that?
5 and negative
5 or negative 5. How many answers did that give you?
5.
2. 2 answers. You plug in one number, you got 2 numbers out. That's a fake function. Any function will plug in one number and you get out one number. It doesn't matter what number it is. It could be 5 bajillion. That's not a number, by the way. But, you get the idea? If I plug in one thing and I get out 5 different answers, fake function. Really, really fake function. Plug in one and get out 2, and plug in one and get out 1, good to go. Make sense? Still follow? All right. Now, how do you tell whether something is really a function in the wild? I assume everybody in here is familiar with the store called Aldi, the grocery store, A-L-D-I. Is that may not been an Aldi? Okay. It's this place, they have a very, very limited selection, but it's usually a little cheaper than anything else. If you go in there looking for like 20 different brands of cream corn, you're going to be disappointed. There's one brand of cream corn. It's just like stacks and stacks and stacks of the exact same brand of cream corn. Just can't, it was an easy one to remember off the top of my head. I'm not an addict of cream corn or anything, just. So let's just say you walk into Aldi and you're buying 12 cans of cream corn. For whatever, you're having a party, you're having, corn chowder or something, I don't know. But you put the thing on the checkout, what do you call it, the belt, thank you, the conveyor thing to do. And what they usually do, if they're really well trained, they scan one of them and then they do times 12 on them. But if they're not, they just go beep, 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 beep 12 times. Now let's pretend it's somebody who's not very experienced. They're scanning all 12 of your cream corns, and I think right now it's 49 cents a can. 45. It just went down. So it's 45 cents a can.
You're studying all of this.
I was prepping the story problem. Okay, and yes, I was a geek walking. Okay, 30-second aside. You wanna get a sample of my life? Join, go into an Aldi sometime and watch me. I'm usually on one knee, with like a geek with my calculator watch out, punching in a bunch of buttons and a whole bunch of people going like, and then they walk by looking a little nervous. That welcome in my life. So what I'm doing, I'm trying to calculate the tax on things and see if I can actually afford what I'm doing. So I'm doing math problems, okay? So you're at the checkout counter, 12 cans of cream corn, identical brand, identical size. They don't come in different sizes, cream corn, as far as I know. They're all like 12.5 ounces or 14.5 ounces. Never mind. So, and they're supposed to be 45 cents, right? So, what would happen if you were me in this case, and you just waited, and you watched the machine go like this? Beep, 45, beep, 45, beep, $1.19, beep, 78 cents, beep, 82 cents. What I would do is, excuse me, hold it. Oh, well, in the chaos, what? What's wrong? The thing is not working properly. What do you mean? Didn't you see that one of those rang up as like $1.19 or 45 cents? There are some people, I mean, they just think the magic machine said it was true, so it must be true. How much do you owe me? Well, 12 cans of cream corn, you owe me $79.62. I don't think so. Wait, back up. Well, I don't know what. That's more than $1 a can. So back up. Let me give you a demo of this. Go ahead and write this down. This is actually relevant. Draw a chart with X and Y. Try this. Let's try number 3. Do 6 threes for X. Let's do.
Thank you.
If you're using any sort of same function at all, what do you think would probably happen in the Y column? Like, I don't even care what function you're using. What do you expect to happen in the Y? They should all be the same number. But if you plug the same number in 6 times, you get the same answer out 6 times, right? Try this. This is Aldi. I don't know if you're aware of this. This is a chart with a bunch of X's and Y's. That's all we know so far. I'm telling you secretly, this is the Aldi cash register. And computers are kind of dumb. They're very fast, but they can't think as we can think. So they don't recognize words. They deal in numbers. You program the scanner to say, there's like, they don't know what cream corn is. They don't eat cream corn. They just say, oh, some guy at the warehouse called this item number 3. Because item number 2 is like canned peas, and item number 1 is like sliced carrots, or who knows. But does that make sense? Like everything has a code. That's what they're scanning is the code. It's like a 10-digit code. It's not a 1-digit code. I'm just trying to make it easy. So this is item number 3. The computer is actually kind of dumb also, because if you have 2 different sizes or something, it is kind of smart. Cream corn normal size would be item number 3. Cream corn double size would be item number 4. You have to give them 2 different codes, because you have 2 different prices. Make sense? What would you say about this cash register? Yeah.
It's not working.
It's not working properly.
You're making a profit.
As a matter of fact, there's a word for it. The cash register is malfunctioning. That's where the word comes from. It's not behaving like a function. If you plug in the same number 6 times, you should get the same output 6 times. One input should give you only one output ever. This thing gave us 4 different outputs. 45, 119, 78, these are cents. So all of a sudden, this, and this
Okay,
That's a problem. The machine is malfunctioning. It's not behaving as a function. If you had an actual function, it would be 3, 3, 3, 3, 3, 3, 45, 45, 45, 45, 45, 45. Now, could they change the price of cream corn? Sure. You know, they could start charging $1.19 for cream corn. I'd go shop elsewhere. But they could do $1.19, $1.19, $1.19, $1.19. At least the thing is functional. I would say the people pricing the stuff are crazy. Or either that or we were in some sort of horrendous famine where cream corn is just getting scarce. But do you see the point? Do you see the principle behind this? A function is where you plug the same thing in multiple times, you get the same thing out multiple times. Okay? Now, let's take a look at, hang on a second. Turn, if you will, your book to page 521. 521. Problem number 1 on the previous page is part of your homework. You have to review to be able to reduce those radicals to.
I don't like those.
Well, they like it. Number 4, on page 521, top of the page. Says this exercise is about the function in inflow, whose equation is y equals 2x plus 5. I do need to tell you one other quick thing. This is probably the last piece of new notes I'll give you. So have your notebook ready. It's very brief, for sure. This is actually, it's kind of a math secret I'm about to spill the beans on. If you have blah, 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 blah equals 0, the blah, blah, blah can be anything. This means something in algebra. When you get something equal to 0, and we've actually been doing that a lot this chapter and last chapter, that means something. Like there could be a mathematician in France, doesn't speak a word of English. And if you do this, he'll know what it means, or she'll know what it means. When you set something equal to 0, you are about to solve. That is the universal code for I'm about to solve something. So, we in America could write x squared plus 3x plus 2 equals 0. And just seeing the equals 0, the mathematician in France is, oh, sacre bleu, they are about to solve. So, they'll just know. Somebody in Germany, Achtung, is going to solve for 0. No, it's all good. Nice. That's just universally true. Okay? Memorize that. Equals 0 means you're going to solve. There are 3 of these I'm going to give you. The second thing, y equals blah, 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 blah. If you set something equal to y, the letter y, it means something else. And again, this blah, blah, blah can be anything. Y equals x squared plus 3 equals 2. That means you're not about to solve, you're about to graph. When you see a y equals in front of anything, that's sort of universal code for I'm about to graph this. One last thing. F of x equals blah, 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 blah. What does that look like? A what? Yeah, function. You're making it look like a function. Those are the 3 things I'd like you to memorize. Equals 0 means solving. Setting a y equals in front means you're about to graph it. Putting f of x in front means you're about to treat it like a function, whether it's fake or not. And here's the teeny last little hint which will be useful in your homework. Y equals x squared, f of x equals x squared. Y and f of x are interchangeable. How come? I was gonna say why, but. So how come? Because one of them treats it like a graph, one of them treats it like a function. It's the same formula, x squared. This one they're gonna graph, this one they're gonna plug in numbers. Okay? So look at the top, page 4, page 521, number 4. It says about the function whose equation is y equals. That should have startled people. It should have been f of x equals. But you can always replace f of x with y, and you can always replace y with f of x. There's no law against it. Number 4a, let's do this together. What is its degree? Somebody tell me what degree means, first of all. Ted, what does degree mean?
It's like the power.
What about the power? Go.
Highest
The
power.
highest power. It's the highest power in the entire problem. And it is 1, correct. The highest power up there is 1, because it's x to the first power. So let me write this down. Y equals, I forgot, what was it already? 2x plus 5. Everybody look up here? There is an invisible 1 as a power for the x. That's the biggest exponent in the problem. I am not counting the exponent on the y. How come? Because the y equals is not part of the formula. Guess what y equals means? Graphing. Don't worry about the power of y, because that's really not part of the formula. It's just saying we're going to graph the formula. What formula? This. This is the output formula. And the highest power in the whole thing is 1. So the degree is 1. What kind of a function is it? We covered this on Friday. What do you call something of degree 1? These in the reading, you know those mystery pages that nobody ever reads in front of homework problem? Yeah, those. Elijah. Linear. But yes, it is having to do with a line. Linear. So the answer for number 4b is linear. Linear. It is a line. Number 4c, what kind of graph does it have? I kind of gave it away. Which, in other words, what shape? A line. It's a line. And number 4d, copy and complete the following table for this function. How would you do that? Joanna. Number 4, part D. How would you fill in that table? They give you a bunch of x's, but how are you supposed to get the y's?
You have to solve the problem on the top.
Kind of. Here's the formula we're using. Y equals 2x plus 5. If you have an x, how do you get the y?
Just plug it in.
Plug it in for x. So for example, the very first one, -2, they already did -3 for you. -2, plug in here. You tell me, Joanna, what's 2 times -2? -4 plus 5?
1.
Close. Oh, so you're right. Yeah. That is, in other words, positive 1. Put that in for your first blank. Positive 1. I was thinking -1. That's better. Everybody okay? On finding the rest of them? You plug in the appropriate value of x to get its matching value of y. E, graph the function. The very first point you should graph is -3, -1, x, y. And then just graph all of the ones in your table. That's why you need the table filled.
Are you gonna give us,
Graph paper. Yes, I hope so. I'll go look and see if somebody stole my graph paper out of the printer, and if so, I'll print more. Yeah.
so are you gonna print like the actual graphs or just have us have graph paper?
If you have your own graph paper, that's awesome, but I will print graph paper for you.
The graphs? Like,
All the graphs, well, yeah,
do we have to draw those?
I'll show you what I mean. I have pre-printed things where it's like 10 by 10. It goes from -10 to 10 and -10 to 10. So those,
So much better.
yeah, I'll just print off some more. I'll do that in a few minutes. Choose a suitable scale, blah, 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 blah. I think that's it. Questions? You okay on this? Okay, your assignment? Homework 13B is in Baker. Don't forget number 1, that's on the previous page. That's a review problem. Number 13B
What?
is going to do
You just haven't done that.
Let me see if the graph paper's over yonder. You're okay.
Yes, yes. You're back at your get graphic thing. That's all. Seasonal calendar. No, I haven't. In the section already picked that. I'm just section 31. Okay.
Got it. Somebody had stuffed them in between a history test and a Latin exam, but there you go. If you need more, I'll put it over on the table over yonder.
Is this 13B?
13B, right.
You're
There's more on the back too, by the way, so there should be 12.
Oh, 13.
So you should have plenty. Oh, no. You just write right on. Just put your name on the top. You'll have your regular assignment for that.
And then there's not.
Or just keep it close. Because we don't turn them in anyway.
But what is it? No, we just.
Use them however you want. So I have had some people recommend.
Yeah. Here's my binder.
And I'll print more as they need arises. Here's the stack. I'll put it over by the disinfectant wipes and stuff. Yeah.
Is this your pop? What's today?
Okay. So you can plug in the names too.
Holy cow.
Sorry, someone's called my name. Yes. Oh, thank you very much. Yes, please.